Hello there, I'm Dominic St-Pierre. I wanted to talk today about the fact that there's no object-oriented programming in Go, basically. So let's have a quick recap to make sure that we are all on the same page regarding OOP. So we can see in here, a simplistic view of what inheritance could be in a certain very simple manner, basically. But usually on programming languages that do favor object orientation, so you tend to have a lot of let's call that multiple level of classes that can inherit from their parent. So in here we would have the utmost parent could be called an object. So if every class in this hierarchy would inherit from that. So we could create a shape class that would have two implementation. Well, maybe not implementation, but two classes that would inherit from this shape. And I have some pseudocode in the bottom, so it's not a language. It's nothing at all. It's just to make sure that we are all on the same page on that. So on that typical structure or hierarchy, if you will. So the shape, can usually have some properties of their own in object-oriented languages, and it can have some method as well that can be called from classes that inherits them, or maybe even override and things like that. We will see that later. But so our rectangle class is inheriting from the shape, and we are able to call its area. So yeah, I know that there's no constructor and things like that. So what is this 5 and 10? Well, let's just assume it's the width and height. So we have something to work on. So that this type of programming is not it's not there in Go. You cannot see your system as being objects, and you don't really inherit in Go. So there's multiple things that resemble object orientation a little bit, but yes, those kind of things. It's not the way that you would organize, or at least create your structure for your code in Go. So let's have a quick look. So basically what we could do is we could have a type shape, and this type would have the width and the height fields. And our rectangle structure, because we only have structure in Go, so there's no object. So a structure is basically just something that do have fields, and we can attach some functions to structure. But in here, in our rectangle and triangle, we can see that we are embedding this shape structure that we created. So what it means is, instead of inheriting, we are not inheriting, because like I am saying, in Go, structures only have basically their fields and their functions that are attached. So it's true that by embedding, we are kind of inheriting, the functionality of the area shape, the shape structure, and the area function is also there. And it's possible to call it from our rectangle, because we do have it from our the fact that we are embedding this, we are able to call that thing. So this is a small distinction that a newcomer to Go needs to start to absorb, because especially if they are very used to object oriented way of doing things. So it's kind of similar in a way, but you know, that's really how you compose your structure in Go. And now, you know, if we execute that code, then, you know, we can see the area of that shape. So, you know, it's not very similar, but you know, on paper, or at least from a super high level point of view, this is extremely similar. But we cannot really override this area function inside our rectangle or triangle structure. So it's not a class. It's just you can see that as if we were to take the structure and everything that is, and we were kind of duplicating its code in our structure. So it's more like that. I would say it's more like a, you know, a don't repeat yourself version of copying the code, more than inheritance in a OOP language. So some other concept, like we talked a little bit about. So, you know, in OOP languages, you might be, you know, used to calling functions and overriding them on your classes that inherits from you know, a parent class, for example. So this shape class could have a doX function, and, you know, in our rectangle, we can, you know, we can directly call this. So this, you know, this is just to show that, you know, in such a languages, you might have the base keyword might be this, you know, it depends, but this refer to the class that you are inheriting from. And also in triangle, we can see that, you know, I use the override keyword in here. It could be it's just a way to say that, you know, the doX function from the shape, well, I want to override it in that specific class. And, you know, from here you can call the doX, and it will, you know, it will do what you think it will do. So again, this does not exist as well, so there's no way to override a function, you know, that. But again, just like the inheritance, there's a Go way to do that. And, you know, this slide is a little bit crowded, and sorry for the code formatting, but, you know, it is what it is. So basically what we have here is we can declare an interface. So in Go, if you have some functionalities that you will want multiple structure to have, or to have their own behavior, if you will, so the doX will be kind of implemented in multiple structures in different way. So the way to do that, you declare an interface, and your structure, so we can see that our if we look at the triangle structure in here, we see that we are kind of defining this doX function. By doing that, automatically the triangle is you know, automatically you know, it's implementing this interface. So it's directly that way. So you don't need to tell you know, you don't need to say anything about the triangle. You don't need to tell it, you know what, you have to inherit, or you have to implement this interface. You implement interface just by satisfying the interface requirements. And our interface requirement, the XOR interface, only requires a structure to define a doX that returns a string. So any structure that have a function that satisfies this is automatically implementing this interface. And this is really the biggest part where Go become very flexible compared to object orientation. So let's have a look in here at the default X. So it's not something that you see usually in Go, but, you know, just to just to kind of replicate what we had in this slide. Basically, the rectangle should not override the do x. It should, like, kind of use what its parent is using. So in Go, you cannot really do that because you don't have inheritance. You don't have anything. So what you can do is maybe what we did with the shape previously. So with the shape, we define a function, and now this could be seen as a default implementation if your structure is going to embed the shape structure that define that. But if not, in this case, in here, we do not have any embedding. So yes, so you need to have a function that could serve as what would be in the base class, if you will, from a OOP point of view. But again, I mean, this is just to show a little bit of differences. It might, this might not be exactly how a good Go version would go, because basically I don't believe I would have defined this default X and whatnot. I might have preferred to implement that in the rectangle. So maybe try to ask myself, why would I need some default functionalities? And if I do need some default functionalities, would it not make sense to have this functionality attached to a structure that I would be embedding in here? I mean, there's a lot of question and just with that, but suffice to say that just to just to replicate what we had in the pseudocode, this is how we do things. And we can see in the main that I'm defining the rec and the triangle function variable, sorry, as the xer. So directly here I'm saying to the compiler, those variable have to satisfy this interface. And yes, so that's why we are able to call those functions. If we execute that, we have the result that we are expecting. So again, I mean, this is just a small difference in. So arguably, I mean, this does the exact same thing as what we have in an object-oriented way, in a sense. It's a little bit different, granted, but the point is, you can still do things. It's just that there's no object, there's no classes. You don't really organize by multiple level of implementation and following down a path of descending some classes that inherits from other classes and things like that. You tend to see, when you are starting to build your system, you tend to see things a little bit simpler, and you don't. Usually you try to not think about interface at first. So if I have a small advice for newcomer to Go, or even people that might not be as familiar with the interface yet in Go, don't sweat it. Don't don't think about interface at first. Think about writing your code, and the interface will emerge at some point. It will be clear. The day that you will need to write another structure, so in our case in here, the triangle. Let's say that when we first started to write our system, we were having only the rectangle structure, and everything was fine, everything was good, the application ran for a couple of weeks, and now someone says, we might need some triangle. And when you will came to your program and start to implement, you will realize that wait a minute, we do have a lot in common in here. And when you do that, when you start to pass things around that have almost the same behavior, not the same behavior, but it's the same kind of structure in terms of, my triangle also have do X. Maybe I should extract an interface. And now all your functions that were expecting a triangle struct, you can change that to receive an XOR instead, the XOR interface, or whatever the interface would be for. And now this is where the power of this, of this way of thinking takes all its sense, or, So it's a mind shift. It's something that is very similar, but a kind of a trap that I've seen in object-oriented programming is sometimes people start to create interface, and they start to become very complicated, or a little bit too maybe not complicated, but just crowded in general, just a little bit too out of scope for some classes that are implementing them. And now you are finding yourself in a situation where there are some functions on the interface that are not even implemented in a certain class because it just does not make sense. And to be frank, I did not really add a great example, so I took something that I've seen a long time ago when I was building an old C# program that needed to send email or send faxes and whatnot. But the point is, at some point you will couple either the interface or either some kind of properties, or it might be the function argument that the function inside the interface need to receive. At some point you will need to couple those kind of things with the different implementation that you will need. And here we are seeing that, well, the send data as a fax number, and it has the fax properties, if you will, and it also has the email. And if we were to have a third, a third implementation of something that can send, we would need to add this there. So I'm not saying that it's a situation that you are seeing often. I'm just saying that there's a danger in object orientation sometimes that I've seen where, yes, the interface kind of get out of control, or whatever how you want to say that, and it reflects into your code, and it makes your code after a long time, 5, 7, 10 years, things starts to get really complicated. So again, in Go, well, it's a little bit simpler. We tend to focus on very, very small interface. So in here we would have the sender interface that only have one function, which is just send. And notice that I'm now using an error instead of the send result. So in our OOP example, I was using a class to communicate, what happened with the send. Is it fine? Is the email bounce, or was the fax line was busy maybe? So again, this return value is also it's coupled with the implementation, and it should not. So in our Go version, I chose to use the error type to communicate what went wrong, and now it could be anything. We will see that. But so our type now in Go, so this might be cumbersome at some point, but for this specific example, the fields that relates to the email sending is inside the email struct, which makes total sense. And the fields that relates to the fax are in the fax structure. I mean, is it not a little bit more clearer? And now, usually maybe those two implementation are on two packages, two separate packages, but just for simplicity they are all on one slide in here. But you can start to see how it could be separated on their own packages. And I'm just defining two error in here that maybe one package would expose, and the fax package could expose the ER busy as well. So again, those are just a different way of thinking on how to structure your code. But we do have this this error mechanism that Go provide us, which enforce communication of what's going on in those errors. So I mean, this is kind of yeah. I mean, to me, it's elegant. I really like that. So again, the send function is implemented only in the email structure. You can imagine that we could do that on the fax as well. But so as soon as we are defining this send function, it implements the interface, and now we can use it, and we could check for the error. So that this is how things are similar in concept and Go with object orientation, but in another sense, not really. I hope this makes a little bit of sense. So I have a couple of tips. So I have might said that a couple of times, but yes, we tend to keep the interface very small and very isolated. If you think about the most commonly known interface in Go, which is probably the all the IO reader, IO writer, the IO read closer. So it's really I don't have the good word, but it's really separated. They could have only one reader and one writer, and the reader could have the read and the close, but they decided to separate those two. So the sometimes you do have an IO reader which don't have a close function, and sometimes you have a IO read closer or something like that. I mean, it's an art. It's very, very, very difficult to nail an interface good, like you tend to see in the standard library. In my experience, at least. Maybe it's just me. Maybe I just have difficulties to name my things, and sometimes I don't know. It just does not always feel good or feel right with the name. And it's just it's not just the name. I mean the what kind of function are you going to put inside there? In my open source project, for example, I have an interface for the database, and there's, I would say, 30 or 35 function in there. So what an interface. But I mean, at some point, sometimes it's not everything that can be small and isolated. I mean, at some point we still need to be productive a little bit. We cannot just agonize on some interface design. But the point is, try to keep it small. Try to not implement them at first. Try to let them come to you, and this is probably where it gets a little bit easier. Also, don't overuse the embedding that we saw. So the shape, when the rectangle and the triangle was embedding the shape structure. So if you start to have multiple level of those embedding, you will not like that. So don't see that as the equivalence of the OOP inheritance. They are not that as well. And I would dare say, I would probably try to never have, more than one level, meaning that what you are embedding does not embed something itself, because now you will have I don't know if I don't think it would be very nice on the code reading part. And this is also something that get complicated in OOP, is that um, when you have so many level of implementation like that, it gets very difficult to debug. Where is that code? Who's responsible for this behavior and things like that? And now you need to climb your way up to the source, and sometimes it could be buried very, very deep. So again, just keep that in mind to keep that almost flat. And also, like I was saying, try to prefer to receive some interface in your function argument, and maybe in your return value, depending if it makes sense or not. This is not a one rule that rules them all, but you will just appreciate yourself when you are starting to use interface effectively in Go. When the declick will be made in your head, and you will start to see your function that, oh, you know what, I could accept an interface in here, and now your test will be easier to write, your code will be easier to write, and you will have so much flexibility if something is to change in the future. Let's be frank, it's always changing. So as soon as you will add multiple other implementation, it should not really have any impact, maybe, or very, very small impact on your code base if you are passing interface around instead of structure. So this is something to keep in mind, because in OOP sometimes, after a long period, and I've maintained 20 years old applications, so I know a little bit about the pain point of what's happening after 7-10 years of a code base, and yes, sometimes just changing or just adding new things, it can be very difficult. And lastly, again, there's nothing more than practice, and in time it will just come. Might take a little bit of time, and I remember my first interfaces were maybe not proper and sexy, but were they working? Yes. And was it better than not having an interface? Yes. So don't worry. Go is a very forgiving language, if I can say that. Don't worry about not having the code perfectly, perfect at first. It's very, very, very easy to refactor in Go. So just keep that in mind. If you like those kind of video, I do sell some courses, and this is how people. If you like my content and you want to support what I'm doing, I have two courses on Go. So the link are in the description below. And on that, see you next time.